Last day we ended on Mendeleev periodic table, where we discussed the demerits of Mendeleev periodic table. So last thing that we were discussing was that like elements or unlike elements were kept in same group. Unlike elements were kept in same group. For example, sodium, potassium, rubidium, cesium were kept with copper, Ag and Au, and their properties were not similar to each other, or rather they have a different set of properties, because one is typical metals. Sodium has heavy tendency to give the electron, whereas the copper might not be having that great tendency to give the electron. Now, next disadvantage was that the like elements were kept separately. For example, Au and Pt, they had similar properties, still they were kept in different groups. So this is also one of the flaw of Mendeleev periodic table. The like elements were kept separately. For example, Au and Pt had similar properties and they were kept in separate groups. Now the next one you can write, the next one you write, the position of lanthanides and actinides. The position of lanthanide and actinide was also not clear. The position of lanthanide and actinide was also not clear. Next demerit you can write, the cause of periodicity was not told. Periodicity का क्या कारण है? Periodicity मतलब elements की properties vary करती हैं या differ करती हैं, इसका कारण क्या है, इस cause को discuss नहीं किया गया था. So the cause of periodicity was also not discussed. So these are some of the flaws of Mendeleev periodic table. Now we will discuss Mosley periodic table or modern form of periodic table. Actually, Mosley conducted an experiment in which he bombarded high speed electrons on the surface of metals. Mosley conducted an experiment in which he bombarded high speed electrons on the surface of metals. In this process, the X-ray was emitted from the surface of metal, and the frequency of this X-ray, or say under root of frequency of X-ray, was directly proportional to Z. The under root of frequency of X-ray was directly proportional to Z. Z is atomic number. Z is atomic number. Based on this experiment, Mosley concluded that based on this experiment, Mosley concluded that the properties of elements are periodic function of their atomic number, periodic function of their atomic number. And this is modern periodic law. If you remember the periodic law given by Mendeleev, he told that the properties of element are periodic function of their atomic masses. Mendeleev told that the properties of element are periodic function of their atomic masses. But here it was concluded that the properties of elements are periodic function of their atomic weights, not masses. This is modern periodic law. मतलब जैसे जैसे हम एटॉमिक नंबर बढ़ाते जाएंगे, एक रेगुलर इंटरवल बाद एलिमेंट्स अपनी प्रॉपर्टीज को रिपीट करने लग जाएगा. शुरुआती रूप में जब मेंडलीफ ने ये लॉ दिया तो उन्होंने बोला जब एलिमेंट को उनके एटॉमिक मास के आधार पर अरेंज करते हैं तो एक रेगुलर इंटरवल के बाद एलिमेंट्स अपनी प्रॉपर्टीज को रिपीट करने लग जाते हैं. जैसा कि we see that when they are arranged on the basis of mass after a interval they tend to repeat their property. But Mendeleev की periodic table में काफी कमियां हैं. A new law was prescribed based on the experiment of Mosley where he said that जब एलिमेंट्स को अरेंज उनके एटॉमिक नंबर के आधार पे करते हैं तो एक निश्चित इंटरवल बाद एलिमेंट अपनी प्रॉपर्टीज को रिपीट करने लग जाता है. एंड दिस इज कॉल्ड एज मॉडर्न पीरियोडिक लॉ prescribed by Mosley. Now, modern periodic table that was based on atomic number, this table had 9 groups. This table had 9 groups. If you remember the periodic table of Mendeleev, it had 8 groups. If you remember the Mendeleev periodic table had 8 groups that were classified into 1A and 1B, 2A, 2B, like this. Here if you see 9 groups were again divided into 1A, 2A, like this. Now what is this 9th group? Mendeleev had only 8 groups. Now what is this 9th group? Actually, this 9th group included noble gases. This 9th group included noble gases. If you remember, Mendeleev periodic table के अंदर noble gases का mention नहीं है because तब तक noble gases की discovery नहीं हुई. It was only after the discovery done by Ramsay that noble gases were discovered by Ramsay. They were put inside the modern periodic table. But before that, till the time of Mendeleev, the knowledge of noble gases were not there. They were not discovered till those times. Therefore, they were not kept into the periodic table. This 9th group is there where the noble gases are kept. Now, what is the basic difference between Mendeleev periodic table and modern form of periodic table? The difference is one extra group has been introduced. एक 9th group आ गया extra group जिसमें noble gases रख दिए. और एक और जो सबसे बड़ा मेजर डिफरेंस है वो डिफरेंस है यहां पर टेबल एटॉमिक नंबर के आधार पर अरेंज किया गया है, वहां पर टेबल एटॉमिक मास के आधार पर अरेंज किया गया. नाउ राइट, Mosley periodic table had 9 groups. The 9th group included noble gases. The 9th group included noble gases after they were discovered by Ramsay. it had 7 periods. Now it is same as that of Mendeleev. Mendeleev also had 7 periods. So it had 7 periods. The table was arranged on the basis of atomic number. The table was arranged on the basis of atomic number. The table was arranged on the basis of atomic number. Now let us study one more. That is long form of periodic table, right? Long form of periodic table. This was given by Bohr, Bury, Reng and Werner. Was given by Bohr, Bury, Reng and Werner. This is long form of periodic table given by Bohr, Bury, Reng, Reng and Werner. This table has 18 groups. This table has 18 groups. If you compare it with Moseley periodic table has 9 groups. If you compare it with Mendeleev periodic table has 8 groups. It has 18 groups and 7 periods. 18 groups and 7 periods. Now let us compare this long form of periodic table with modern form of periodic table. Now there are 18 groups. Now see this one. This is 1A and this is 2A. Now you see this is 1A, this is 2A. Now this is 3A and then 4A, then 5A, then 6A, then 7A and then write it as 0 group. Write it as 0 group or inert gases. 0 group or inert gases. Now if you see here, scandium, titanium, vanadium, chromium, Mn, Fe, cobalt, nickel, copper and zinc. Now if you see this one, this is 3B, this is 4B, this is 5B, 6B, 7B, and this is 8th group. This is 8th group. Eighth group, and this is 1B and this is 2B, like this. This is 3A, 4A, 5A, 6A, 7A and 0 group. So if somebody asks you, compare the group of Mendeleev periodic table or modern form of periodic table with the long form of periodic table, तो जो long form of periodic table में element 1B में था, वो long form of periodic table में कहाँ पे? मतलब जो modern form of periodic, मॉस्ले की जो periodic table थी, उसके अंदर जो element 1B में था, वो long form of periodic table में किस group के अंदर है? तो you will say that 11th group में. यदि कोई बोलता है कि 1A में जो element था, वो किस column में है? तो that is in first column. This is first column. This is second column. First column, second column, third, fourth, fifth, sixth, and then 18th. So if you compare the position of elements of Mosley periodic table with the position of elements in the long form of periodic table, you should write it like this: 1A, 2A, और उसके बाद में B चलता है, और यहां से फिर से 3A, 4A, 5A, 6A, 7A और 0 चलता है. Unfortunately, if you see NCERT के अंदर इस पूरे एरिया को A लिखा हुआ है, which is completely wrong. This is B, this is not A. If you see the text, then यहां पूरे को A लिखा हुआ है, मतलब वो 3A, 4A, 5A इसको लिखते हैं, एब्सोल्युटली गलत है. A 3B है, ये 4B है, ये 5B है, जबकि इसको उन्होंने 3B लिखा हुआ है, जबकि ये 3A है. So remember this, don't get confused by that. There is a mistake in that. This is correct. 3A, 4A, 5A, 6A, 7A and 0 group element. Okay, text. Now note it. Now write nomenclature of elements. Nomenclature of elements having atomic number greater than 100. Atomic number greater than 100. The IUPAC has given the name, so they give the name like prefix plus suffix. So you should write one prefix and then the suffix. So IUPAC has prescribed the names. For 0, you should write nil. For 1, un. For 2, by. For 3, try. For 4, quad. For 5, pent. For 6, hex. For 7, sept. For 8, oct. For 9, n. For 0 you should write nil. For 1 you should write un. For 2 you should write by. For 3 it is try. For 4 it is quad. For 5 it is pent. For 6 it is hex. For 7 it is sept. For 8 it is oct. And for 9 it is n. E-N-N-N. And after you write these numbers, the suffix should be written as EM. The suffix should be written as EM. For example, if I want to write the name for 101, for 1 I will write un, for 0 I will write nil, for 1 again I will write un, and then add suffix em. So the name becomes unnil unem. So the name becomes unnil unem. Unnil unem. For example, I want to write it for 102. For example, if I want to write it for 102, then the name will be unnil by em. But in this case, there is a repetition of I. One I is removed, and we will write the name as unnil by like this. Unnil by You can write it for, you can try it for 109. Try it for 109. Try it for some hypothetical figure, say 602. Write it. Yes,
Unnil unem.
Unnil unem.
Unnil anem.
Okay, name for 109.
Yes, sir.
Yes. Unnil and em. Correct. For 602.
Hex nil by em.
Hex nil by
em.
1 I should be removed or not?
Yes, sir.
Okay. Bm. Good. Now I will give you a general idea of periodic table, and then I will teach you more classification on periodic table, where he has divided the element into 3-4 categories. We will discuss that. But before that, we will discuss something. Now see, there is hydrogen placed on the top of the table, one number. Then you have lithium, sodium, potassium, rubidium, cesium, and one more, that is francium. Here you will have beryllium, magnesium, subsequently radium, barium, strontium, calcium. Now move like this. Here we will have scandium, थोड़ी देर पहले मैंने यहाँ तक लिख दिया, इसलिए यू मस्ट हैव अंडरस्टूड दैट कौन कौन से एलिमेंट यहाँ पे आने वाले. इसके बाद में यहाँ देखेंगे तो आप स्कैंडियम के बाद प्लेटिनियम, एंड हियर यू हैव lanthanum, and here you have actinium. Now if you want to see here, here it is gallium, और इसके ऊपर aluminium and boron. It will go further till neon. Above that you have helium. Good. Now see here. This is S block. This is transitional elements. And this is P P block elements. P block elements. The first two are S block, then you have transitional element, and then you will have P block elements. And if you note that this is 3B, I wrote sometimes before, this is 3B or third column, this is 3B or third column. Now, if you see here, in periodic table it is somewhat star marked, and this position is also somewhat star marked. This is for lanthanides. All lanthanides are placed here. सब lanthanide यहाँ होते हैं, and all actinides are placed here. Lanthanides, and then there are actinides which are placed over here. Now there are 14 lanthanides and 14 actinides, and also remember that this lanthanum and this actinum, this lanthanum and this actinum are part of D block, not lanthanides or actinides. जो lanthanum है, it is a part of D, it is a D block element, it is not part of lanthanide series. This actinum is a part of D block element, it is not a part of actinide series. यहां पर आपको टोटल 15 एलिमेंट इस कॉलम में मिलने वाले, इस ब्लॉक में टोटल एलिमेंट आपको 15 मिलेंगे, एक लैंथनम प्लस 14 लैंथनाइड्स, और यहां पे टोटल 15 मिलेंगे, एक एक्टिनम प्लस 14 एक्टिनाइड्स. Now if you have a little bit of understanding about the periodic table, I will explain it further. The Bohr's classification of elements. Now write Bohr's classification of elements. He classified the element as inert gases or zero group elements, obviously their electronic configuration is ns2 np6. Their electronic configuration is ns2 np6. Their shell is completely filled, therefore they are inert elements, they do not show chemical reactivity. They are inert elements, they do not show chemical reactivity. And their electronic configuration is ns2 np6. All noble gases, all elements of this group are gases. All elements of this group are gases, from helium to the neon, argon, krypton, xenon, radon. All are gases, from helium to radon, and are called as noble gases because they are non-reactive in nature. Are called as noble gases since they are non-reactive in nature. Now next category was normal or representative element. Bohr classified the elements into noble gases or say inert gases, then normal or representative elements. Now this normal or representative elements were S and P block elements, therefore they will lie in 1A, 2A, this is S block, and then 3A, 4A, 5A, 6A, 7A and 0 group. This is P block. All elements of S block and P block are called as normal or representative elements. Obviously the properties of these elements we will read in their consecutive chapters of S block and P block. Right now we are just mentioning the classification part. The classification part, noble gases number 1 type and number 2 type, normal or representative,